Good evening. Nobody has come. What should I do? Uh, who? Sai Kalyan. One person is Sai Kalyan. I don't recognize. Who is the next person? Samsung SM. Who is seeing the... Hello? Are you all there?
Yes, ma'am.
Yeah. So who is on Samsung phone? Tell me your name.
Vishal,
Vishal.
new admission.
Oh, you are new. So can you switch on your camera for a while?
Yes, for 1 minute.
Hello, Vishal. So how will you manage, Vishal, all the portions that you have missed? You'll go through the videos and manage it? You switch on you are muted.
Yes, ma'am. I'll manage watching the videos. Previous.
You'll be watching the videos.
Yes.
Because to start from the middle, I think you may have a little difficulty. So you will have to talk to your, you know, uh, these people in learning room and see how you can manage it. Okay, so
Okay.
please try to do that. Anyway, today I'm starting with electrolysis, so you can start from it afresh. What are the topics that you have learned in school?
Um, alcohols and phenols. That's
Alcohols and phenols you have finished. Then what else have
yes.
you done? Electro.
Alloalkanes and allocanes.
Okay, very good. Then electrochemistry
Mm,
have you done?
they are going to start in next week.
Okay. Okay, so we have finished almost the first part of electrochemistry. So today we will do the second part of electrochemistry. So I'm going to start that. I'm just waiting for some others to join, but we have already waited for 10 minutes. So doesn't matter, we will continue.
Okay.
So Vishal, since you are joining today, I would like to say that it will be very nice if you can keep your camera open.
Okay.
If for some reason you are not able to, I do understand, but as far as possible, do that. And also, if you have doubts, you can always stop me and ask. I will explain. Okay.
Okay.
So now I'll share my screen. So I have to complete a few cells. I can do that later. Right now, I'm going to start with the new topic, and that is electrolysis, electrolytic cells and electrolysis. Sai Kalyan, are you there? Sai
Yes, ma'am.
Kalyan, are you? Hmm. You have already done this part, right?
Yes, ma'am.
Sai, yes, electrolysis. So you keep answering and helping me. So till now we did the first part of electrochemistry. We were looking at those chemical reactions where the chemical reaction, electricity is produced as a result of chemical reaction. So the chemical reaction produces electricity, and those cells which we learned there, they were all galvanic cells. So galvanic cells are those cells where a chemical reaction produces electricity. So these are those reactions where, supposing I have a component element A and a element B, and element A has a tendency to give electrons and element B has a tendency to accept electrons. So if I connect A and B, the electrons will start flowing from A to B and electricity will be generated. But if I take another set of things, C and D, now C does not want to give electrons to D, but I want C to give electrons to D. So I will have to force electrons take electrons forcibly out from C, and D does not want to take, so I forcibly want to give the electrons to D. So then I will have to make use of current to bring about this chemical reaction. So what will I have to do? I will have to make use of a source of energy, say a cell. And what will this source of energy do? It will pull electrons from C and it will push them towards D. Okay. Now, in this case, we are making use of what? Electricity to bring about a reaction which is otherwise not spontaneous, or a reaction which does not take place otherwise. We are forcing that reaction to happen. Then the process that happens in such cases is electrolysis, and the cell that is produced now or we make now for bringing for electrolysis to take place is known as an electrolytic cell. So we will now look at an electrolytic cell. How does the electrolytic cell work? So first we take a container. Just keep in mind what we have learned, Sai Kalyan, what we have learned in case of galvanic cell. Now here there is a single container. This container we call it as a electrolytic cell. And this is generally made of a inert material. Then in this container, we put two electrodes. Right? These are the two electrodes. These are known as electrodes. And they are the ones which are connected to the external source of energy. Right? And the electrode, which is the smaller line, represents what? The smaller line represents negative end of the battery, and larger line shows the positive end of the battery. So the electrode which is connected to the negative end of the battery is the negative electrode. And the electrode which is connected to the positive end of the battery, we call it the positive electrode. Now what we do is we fill in an electrolyte. Now what is an electrolyte? We have already learned. Electrolyte is a solution which has ions which can conduct electricity. Electrolytes conduct electricity by movement of ions. So electrolyte is a solution which has mobile ions. So this is the electrolyte. Okay. Now these electrodes can be either inert electrodes or they can be active electrodes. The first example that I will take, they are basically inert electrodes. Inert electrodes can be made of either platinum or graphite. So these electrodes will not take part in the reaction. Now the moment I put these electrodes into this and the electrolyte into the electrolyte, what will happen? Now let us take an electrolyte. This time the electrolyte that I take is molten sodium chloride, molten sodium chloride. So what does molten sodium chloride contain? Molten sodium chloride has NaCl, it has Na plus Cl minus. These ions. So the moment I melt sodium chloride, it will have sodium ions and it will have chloride ions. What do I call the sodium ions? Sodium ions are the cations. And the chloride ions are what? Anions. Now what will happen? So the moment I put these electrodes in the electrolyte, what will happen? The positively charged ions, they will start getting attracted towards the negative electrode, right? Where will the positively charged ions go? They will go towards the negative electrode. So the sodium ions, they will start moving towards the negative electrode. This is the negative electrode, right? So on this side, the sodium ions will start moving. So what will happen there? Sodium ions will move towards the negative electrode and chloride ions will start moving towards the positive electrode. The moment I pass current through it, the ions will start moving there. Now, why is this electrode negative? Because it is connected to the negative terminal of the battery. So the electrons are flowing here. This is negative because electrons are flowing into the electrolyte through the external source into this electrode. So there are excess of electrons here. So this positively charged ion, that is sodium ion, will accept electrons from here and become Na. Right? It will become Na. And what will happen to the other side? The chloride ions, this is the positive terminal of the battery. So what will happen? The chloride ions positive terminal is deficient in electrons. So chloride ions will give out their electrons. So they will change into Cl and they will give electrons. Electrons will be given out. And chlorine is not stable. So Cl and Cl, two chlorine atoms will combine to give chlorine. That will happen at the this side is which electrode I am talking about? This is the positive electrode. And this one is the negative electrode. This is happening at the negative electrode. Now, Sai Kalyan, can you tell me what is the reaction that is happening at the negative electrode? Can you tell me what reaction is happening at the negative electrode?
Reduction, miss.
So at the negative electrode, reduction is taking place. This is reduction. And at the positive electrode, what is happening? Oxidation. Right? And I told you, where does oxidation take place always? Where does oxidation take place always? Always oxidation, the electrode at which oxidation takes place is known as what? Anode. Right? So this becomes your anode. And since reduction is taking place, this becomes your cathode. Right? So here there is a little difference compared to the galvanic cell. In galvanic cell, we say in galvanic cell also oxidation takes place at anode and reduction takes place at cathode. But in the galvanic cell, the negative electrode is the anode and the positive electrode is the cathode. But here, the negative electrode where the electrode where oxidation takes place is anode only, but that is the positive electrode. And the electrode where reduction takes place is the cathode, and that electrode is the negative electrode. So that little change is there. Otherwise, oxidation at anode and reduction at cathode does not change. To remember this, you can learn this word, which, like I gave you one word in case of galvanic cell, here I will give a word, it is panic. Okay, so in an electrolytic cell, positive is anode and negative is cathode. So you have to remember the ions that move towards cathode are cations, the ions which move towards anode are anions. So anions, you know, are negatively charged, so anode has to be positive, and cations are negatively charged, so cathode has to be negative. Okay, so that is how you remember in case of a electrolytic cell. So the process that took place here, what was the reaction? Sodium chloride was changed into sodium and chlorine. Normally what happens, sodium and chlorine combine spontaneously and give you sodium chloride. That reaction happens. But sodium chloride, to make it change into sodium and chlorine, it is very difficult. You can do it only with the help of electricity. So this process is known as what? Electrolysis. So what are we learning here? Electrolysis. Okay. Now in this case, there was no problem. Why there was no problem? Because we had only two ions, two types of ions, cations and anions. So cations got discharged at the cathode and anions got discharged at the anode. Now supposing I have another electrolytic cell. This time I have another electrolytic cell. So let me draw the electrolytic cell once again. And this time I have an electrolyte which is sodium chloride solution. It is sodium chloride solution. Okay. So sodium chloride solution, and here I have two electrodes which are inert electrodes, and carefully show which is the cathode and which is the anode. It is not necessary that the left should be cathode and right should be anode. You can draw it anyway. But here anyway, what right now you have drawn this negative is cathode and this is the anode. Now let us see what happens in this case. So you have a sodium chloride solution. Now in case, now this will help you to understand that there will be, if there are more than one type of ions in solution, then there will be always a competition that will take place. And which ion will get discharged will depend on the electrode, reduction potential of that particular ion. So in case of sodium chloride solution, what do we have? We have NaCl, which ionizes to give you Na plus Cl minus. And you also have water. You also have water. You can say water can ionize into H plus OH minus, just to make it easy. Water does not ionize easily, but in the case of NaCl, whatever, there is some H plus ion. So if I try to see what is happening at cathode and what is happening at anode, so you see what are a cathode, what ions will go to the cathode? The cations. So what are the cations? Na plus and H plus. Two types of ions are there, Na plus and H plus. So you look at the table of reduction potentials, you will realize that Na plus E minus, it gives you Na, and the reduction potential for this is equal to minus 2.71 volts for this reaction. And for H, H plus E minus will give you half H2, and that will be equal to 0 volts. Okay. What is the reaction that will happen at cathode? You know, it is reduction. So which of the two will get reduced? The one which has higher reduction potential, right? The one which has higher reduction potential will get reduced. Where? At the cathode. So sodium will not get, this reaction will not take place. Okay, so which reaction? This reaction will not take place. Why? Because the reduction potential of sodium is higher than the reduction potential of hydrogen, right? Is lower, sorry, is lower than the reduction potential of hydrogen. It is minus 2.71 and hydrogen is 0. So reduction potential of hydrogen is higher. So what will be discharged at the cathode? It will be hydrogen. So what will be the reaction at cathode? The reaction at cathode uh, will be, you can write H plus E minus, giving half H2. So the product at cathode will be hydrogen. You were hydrogen gas. So what were you expecting the product of at cathode to be? You were expecting sodium, but instead of sodium, what did you get? You got hydrogen. Why? Because the reduction potential of hydrogen is higher than that of sodium. Now you go towards the anode. Let us see what will happen at the anode. Now at anode, there are, what are the two things present at the anode? Vishal, can you tell me which are the anions present at the anode?
Hmm.
Hmm? What are the ions at the anode?
OH minus,
Yes, OH minus and Cl minus,
Cl
right?
minus.
So they will start moving towards the anode. This OH minus is actually water. Mainly it is water, not completely ionized, but to make it easy, I have written that it ionizes to give OH minus. So these two ions, they start moving, and what is the reduction potential? The reduction potential of both of them, I will show you the two reactions. So Cl minus uh, will give half Cl2 plus E minus, and for this it is 1.36 volts. Okay, now on this anode, what is the reaction that is taking place? At anode, it is oxidation. Okay, it is oxidation. So this is the oxidation potentials that are written. Minus is changing to 0, the oxidation potential. The other reaction that could be happening here is water is changing into oxygen, O2 gas plus 4H plus 4E minus. And for this, these values are given in the table that I told you. Here it is 1.23 volts. Okay, so what is happening to oxygen? From -2, it is changing to 0. So these are written as oxidation potential. So what should happen here? Oxidation should take place. So the one which has higher oxidation potential should get oxidized. Right? So the reaction at anode will be reduction minus to 0. Okay, but here it is chlorine. There is something which happens. There is something which is known as over potential of oxygen. There is some special thing which happens on the anode, and because of that, Cl gets discharged. So the product at anode becomes chlorine. So product at anode is this reaction Cl minus giving half Cl2 plus E minus, and the product at anode becomes chlorine gas. Okay, so what is left behind in this solution? The solution which we started with was NaCl, right? After some times, what will happen? The chloride ions get discharged as chlorine. Water molecules, from water molecules, hydrogen gets discharged as hydrogen gas. So here you get chlorine, and here you get hydrogen, right? And this solution, what happens to the solution? In case of the solution, what happens is, now what is remaining? You have Na plus ions and OH minus ions, right? So you started with sodium chloride solution. After some time, it becomes an alkaline solution of sodium hydroxide. This is a method by which sodium chloride, salt water, seawater is converted to sodium hydroxide. So the two gases, hydrogen and chlorine, are collected and separately, and the electrolyte slowly after some time changes into sodium hydroxide. So these are different advantages of this process of electrolysis. Now let me take just one more example for you to understand different types of products that can happen. Now supposing you have a electrolytic cell. Now this time the electrolytic cell, you have, this is my electrolytic cell, and these are my two inert electrodes. This is cathode and the other one is anode. And the electrolyte that I fill in here, it is the copper sulfate solution, right? It is copper sulfate solution, right? So let us see what will be the reactions at cathode and anode. So we can write here on the left side, we can write the reaction at cathode, and here we write the reaction at anode. Okay, children, are you all there? At least only two participants. Vishal? Hello? Hello? Vishal, are you there?
Yes, ma'am.
Where did the others disappear? Just hold on for a minute. Let me find out what is happening.
Okay, ma'am.
Hello? Hello, Bhaskar. What has happened is that, in the beginning of the class, कह रहे हैं उसको पढ़ा दो कोई
क्या क्या पढ़ा रहे हो? बीच में क्लास में से कुछ you should take them to task.
Hello, Vishal. Vishal, are you there?
Ma'am. Yes, ma'am.
Yeah. So Vishal, what I'm going to do is I'm going to, just take half an hour more because you have joined new. Sir said, doesn't matter. I can teach you alone just the first part of this topic so that you can understand what we are talking about, right? So I
Okay.
will just take a new PPT just for you and I will explain to you the first part of what we did quickly so that you can catch up with others in the next class, right? So we'll do that.
Okay.
File, new. Okay. So you please keep saying something because I don't understand. If I don't see you or your camera is not, if it is not difficult, can you please switch on your camera so that I can see you?
Ma'am, if I switch on, it's getting, I can't hear your voice properly. It's getting break.
Okay. Okay. So you please keep responding in between so that I know you are around, right?
Okay.
So the first part of electrochemistry that you missed in the beginning, in the first part, what we talk about is those reactions which produce electricity. Okay, so the reactions where electricity is produced, and those reactions we talk about, electricity is produced. Produced how? By a chemical reaction. Okay, by when a chemical reaction takes place, electricity is produced. Okay, so what we do here is that how did we understand this? So supposing I take a container and in this container I take say a copper sulfate solution. Okay, so what did I put in this container? Copper sulfate solution. And in this copper sulfate solution, I put a rod in it, which is, let me add one color. So I put a rod in it, which is of zinc, right? So I put a zinc rod in this solution. Okay. And I take another container. I take another container in which in this container, I take a zinc sulfate solution. Right? And what I do is I put a copper rod in it. And I leave it for some time. Right? I leave it for some time. So what happens is that after some time, I make an observation. So in case of copper sulfate solution, what do I observe? There are certain observations which I see. After some time, this blue color of copper sulfate disappears. Okay. And on the surface of zinc, what I see? I see a deposit of copper. Right? So what has actually happened here? What has happened here is that zinc and copper sulfate, there is a reaction. I got zinc sulfate and copper. So copper got deposited on the surface of zinc, and this was the reaction. In this case, I see no change. So what do I understand? That if I say copper and zinc sulfate, there is no reaction, right? But between zinc and copper sulfate, there is a reaction. Did you understand that there is a reaction? So here also we think probably there should be copper sulfate and zinc should be formed, but that reaction doesn't take place. But here this reaction takes place. So for this case, what do we try to let us write the reaction. So what was the reaction? It was copper sulfate plus zinc.
Zinc
If zinc sulfate plus copper.
plus copper.
Okay. I can write, let us write the ionic equation for this reaction. What is the ionic equation? Copper sulfate Cu2 plus SO4 2 minus. You know, copper sulfate is made of two ions, copper ions and sulfate ions. So when I put it in water aqueous solution, I will get copper ions and zinc ions. This is zinc, which is solid. So this is in aqueous solution. This is also in aqueous solution, and this is solid, right? And on this side, I can write the same for zinc, Zn2 plus, which is in aqueous solution, plus SO4 2 minus, which is also in aqueous solution, and we get copper, which is solid. Now this sulfate and this sulfate I can cancel. So what is the reaction which remains? I get Zn plus Cu2 plus, giving Zn2 plus Cu. Now see what is happening here. Zinc is changing to Zn2 plus and Cu2 plus is changing to Cu, right? Now, how do I write this reaction? How has zinc? So let us write the two reactions separately. So Zn has changed to Zn2 plus. How can Zn change to Zn2 plus? Probably it has lost 2 electrons, right? And what is happening to copper? Cu2 plus, how does it change into Cu? It has gained 2 electrons, right? Now, what is loss of the, here what is happening? Loss of electrons. And what is happening here? Gain of electrons, right? So what is loss of electrons known as? Do you know what is loss of electrons?
Loss of electrons.
See, there is, no. So here you should remember oil rig. What does oil stand for? Oxidation is loss and reduction is gain. Okay, so oxidation is loss. So loss of electrons is what? Oxidation. And gain of electrons is what? Reduction. So what type of reaction is taking place here? Redox reaction, where zinc is giving electrons and copper is gaining electrons, right? So when I did the reaction inside this container, zinc was giving electrons and copper was gaining electrons. So here exchange of electrons was taking place here. In this place, exchange of electrons was happening. Now, if I exchange of electrons, now what is movement of electrons? Movement of electrons is known as electricity, isn't it? So if I separate the reaction of zinc from copper and I connect them to the two, what will happen? The electrons will start flowing from zinc to copper. So I will show that now. So what I will do here is now I will take two containers, separated the two reactions, two containers, right? In one container, I take zinc rod. This is zinc rod. And I place the zinc rod, this is zinc rod. and I place it in zinc sulfate solution. And on the other side, I take a copper rod, right? And I place this copper rod in copper sulfate solution. This is copper, right? So what is the tendency of zinc? Zinc has a tendency to lose electrons and copper has a tendency to gain electrons. So the two reactions I have separated them. I have done them in two compartments. So what is continuously happening here in this compartment? What is continuously happening? Zn is changing into Zn2 plus 2E minus. So zinc is continuously going down here as Zn2 plus ions. Zn2 plus ions are forming here, right? And what is happening? Electrons are getting collected on this rod. Now, if I connect these two with a wire, I connect these two with a wire, right? Then what will happen? In this right side, what was happening? Cu2 plus is gaining electrons to become, waiting to gain electrons to become copper. So these electrons here, there is a deficiency, here there is excess. So electrons will start flowing in this direction, right? And they will come here. So what is flow of electrons? Electrons are flowing in this direction. And you know, if electrons flow in the one direction, the current will start flowing in the other direction. So if I put a bulb here, right? If I put a bulb here, what will happen? The bulb will light up because of the flow of electrons, right? So what did I do? I produced electricity, right? And this cell by which we produced electricity, it is known as the galvanic cell. Okay, all the cells that you use in your laptop and in your batteries, in your torches, they are all galvanic cells, different types. This is the most basic galvanic cell. Obviously, this big, two compartments with two solutions cannot be used. But yes, if you can make it in your lab, you can definitely light a small bulb with this cell. Okay, now what is happening here? Here, zinc 2 plus ions. Here there will be what? Excess of zinc 2 plus ions. And these zinc 2 plus ions, what will they do? They will start collecting around this electrode. Why? Because this is rich in electrons. So these zinc 2 plus ions will assemble here and they will prevent formation of more zinc 2 plus. And here what is happening? More copper is 2 plus is getting changing into copper, and sulfate ions will, excess of sulfate ions will gather in the solution. And these sulfate ions, this electrode is positively charged, so excess of sulfate ions, they will start gathering here. So that will prevent the reaction from happening. And to complete the circuit, here you saw in one direction, but it cannot continue for a longer time. So to continue this reaction, what we do is we put a inverted tube here. This inverted tube. And this inverted tube is filled with an electrolyte, a solid electrolyte, like, for example, ammonium chloride. Ammonium chloride. I cannot put ammonium chloride solution. So it's a mixture of ammonium chloride and some gel and that solution here. So these, what will happen? This ammonium ions and chloride ions will be formed, NH4 plus and Cl minus. Now ammonium ions will start moving in this direction and chloride ions will be attracted in this direction. So what will come here in this direction? It will be chloride ions. And they will attract zinc towards itself and ammonium ions will start attracting sulfate. Now, so that the reaction continues. Now, this is known as the salt bridge. Okay, so few names you have to learn. So salt bridge, it helps in continue. If I don't have a salt bridge, the reaction will stop. in no time. So this helps the reaction to continue. Now let us give a few names to different electrodes that the reaction is taking place. So here the electrode where what is happening at the left electrode, oxidation. So electrode where oxidation takes place, right? That electrode is known as anode. Anode is an electrode where always oxidation will take place. If you, in the beginning of the lesson when I was doing electrolysis, there also you saw anode was, I told you, the electrode where oxidation takes place. And here where reduction takes place, this electrode where reduction takes place, right? That electrode is known as cathode, right? And this electrode is where there is, excess of electrons. What is it? What is the nature of this electrode? It will be negative, negatively charged. And cathode here, where lot of deficiency of electrons is there, that will be the positive electrode. Now, this is what I was saying. In electrolysis, it is the anode is negative and cathode is positive. But in a galvanic cell, it is opposite. However, the reaction at anode and cathode remains the same. Always the reaction at anode and cathode is always the same. Okay, so this is what we, now to remember this again, I always have these small words which help you to remember. In this case, you can remember the word lone, L-O-A-N. What does lone stand for? Left oxidation, anode negative. Okay, so it is left side. You generally draw show oxidation at anode, and that is negative. Left oxidation, anode negative, right? Now let us learn a little more, then we will stop. So now I need to represent the cell. How do I represent the cell? Okay, I need to, who else came back? Hari Raghav came back. Hari Raghav, what happened to you?
Ma'am, network issue.
Oh
So
my
past
God, please do something about your network. I thought you have left. So I started teaching Vishal alone. So you also revise whatever I have taught
Ma'am,
Vishal.
can you show the third slide, ma'am?
What is it?
Third slide, can you show, ma'am?
I didn't hear you.
Third slide, ma'am. Third slide.
First slide. You want to see the first
Third
slide?
one, ma'am. Third one.
Third one. So this is this slide. So Hari Raghav, because many others have not joined today, it is because many people are having their exams. So we have decided not to teach anything new today. And Vishal, since he is new, I am teaching Vishal. So you can also revise along with him. Okay? Hari Raghav,
Yes, ma'am.
did
Ma'am,
you
yes, done.
understand? Did you
Yes, ma'am.
understand what I am saying? I am saying today I am teaching only Vishal, the first part which he had missed out. Now you can also go through that along with me, with us, so that
Yes,
you
ma'am.
understand. I am not teaching the new part today because many of you are not present, and they are, all of you, many are having exams, so you have already expressed difficulty. So that is how I am not taking the class. Okay. So now we will continue. Did you understand now? Vishal, up to here, is it clear to you?
Yes, ma'am.
Yeah. So what always happens at anode? It is always oxidation. And what happens always at cathode? It is always
It's
reduction.
reduction.
Okay. Now we will learn a few things. The next thing that we need to learn is what you call the cell reaction. You have to learn to write a cell reaction. So when you write a cell reaction, you write the reaction, first you write the reaction at anode, which is the oxidation half cell. So what is the reaction in this case? At anode, Zn giving Zn2 plus 2E minus. Second, you write the reaction always at cathode. What is the reaction at cathode? It is Cu2 plus 2E minus giving Cu. When you write a cell reaction, make sure that the number of electrons given out are equal to the number of electrons accepted, absorbed. So the cell reaction will become Zn plus Cu2 plus giving Zn2 plus Cu. Okay, so that is the cell reaction. The next thing you should learn to write is cell notation. Cell notation. How do you write cell notation? First, in the middle, you draw a double line. This double line shows Hari Raga. What does the double line show? Hari Raga.
Yes, ma'am.
What does the double line show?
Is it double bond?
The double line here, what does it show? You know it, isn't it? It shows the salt bridge. It shows the salt bridge. So on the left side, you show the cell at the left. So what do you show here? What is happening here? Zn is changing to Zn2 plus. On the right side, what is happening? Cu2 plus is changing to Cu.
Cu.
So in the left side, you show the reaction at anode. On the right, you show the reaction at cathode. Also, it is important that you write the state of each reactant and product. So here, zinc is solid. Zn2 plus is aqueous. Whatever is the ion is aqueous, and whatever is formed, that is solid. And below that, you also write the concentration of this solution. So it is always, for a standard cell, it is 1 molar, 1 mole per liter. Right? And this reaction, this is a cell notation for a standard cell. Okay, cell notation for a standard cell. In a standard cell, the electrolytes, both electrolytes will have a concentration of 1 molar. And the temperature always is 298 Kelvin. Okay, now ultimately we should find out what is the, my cell, how much current will it produce. Okay, so for finding that out, we can do something. What should we do? To find that out, we find what you call the EMF of the cell. So we call it E cell. E0 cell is the EMF of the cell, or which helps us in finding how much current does the cell produce. And that is equal to E0 cathode minus E0 anode. Okay, so E0 cathode means reduction potential of cathode. Reduction potential of cathode. And is written as E0 cathode. And reduction potential of anode it is given as E0 anode. Okay, so E cell is equal to what? E0 cathode minus E0 anode. Now these values will be given to you. So in case of the what is, how will this value be given to you for cathode in this particular cell? What is the cathode? Cathode is where the reduction of copper is taking place. So it will be written as Cu2 plus 2Cu. It is given as 0. This, there is a whole table, 3-4 volts. Okay. And reduction potential of anode, that will be given to you Zn2 plus 2Zn. That will be equal to minus 0.76 volts. When we calculate the E cell, we only use the reduction potential. How will you know that this is a reduction potential? The reduction potential is when the element is getting reduced. So the Cu2 plus has oxidation state 2 and it is becoming 0 here. Here also 2 to 0. So when the oxidation number is reducing, that means reduction is taking place. So the reduction, what is reduction potential and oxidation potential? I'll explain to you in another class. But this is the value which will be given to you in the question. So if I want to find the E cell of this one, what will be the E0 cell for this galvanic cell? It will be E cathode, that is plus 0.34 minus 0.76. Right? So that will become equal to 1.1 volt. Okay. So this cell where we have anode as the zinc and cathode as copper can produce 1.1 volt of current. Did you understand this much?
Yes, ma'am.
So different cells will have different elements, and depending on the difference in their reduction potential, they will produce current. The one which has higher reduction potential. Reduction potential is the ability to get reduced. The one, where does the reduction take place? At cathode. So the one which has higher reduction potential will always be the cathode. The one which has lower reduction potential will always be the anode. Now lithium cells are the best ones, because if I take lithium and copper, lithium has a very low reduction potential and copper has a high reduction potential. So the difference in the reduction potential will be large. So it will produce about 3 volts of current. However, this one is producing how much? Only 1.1 volt.
1 volt.
Right? So this is the first part. I hope you have a NCERT textbook. Just go through the first part and try to understand. And my videos of the first 2 chapters, haloalkanes and haloarenes, are there. You can ask for them and you can complete the studying that part. All right. Oh, Sai Kalyan, you are back. What happened to you, Sai Kalyan?
This network issue.
Is it raining heavily in Chennai?
Not in my area, miss.
So what happened? You know what happened when you also disappeared? Only Vishal was there. So I talked to those people and asked, what should I do? Because it's a new topic that I was starting at electrolysis. So they said, because Vishal is new, you continue teaching the old part to Vishal for 1 hour. And all others have not attended the class today because they are all having exams. So that is why they have excused themselves. So I don't want to teach something new when
I'm also having exams.
Huh?
I'm also having exams.
Yeah, so nice of you to have attended the class today. Anyway, I didn't realize when you joined, but anyway, now I will end the class today. Today's class is only 1 hour, and we will compensate for this class on some other day. All right?
Okay.
Okay then. Vishal, please see the videos and then.
Okay.
Okay then. Bye. Sai Kalyan, all the best for your test.
Okay.
What exam do you have tomorrow, Sai Kalyan?
Physics, miss.
Physics. Okay, so you please study physics. Okay, then see you. Bye.